Welcome back to Learning How to Learn. What would it be like if you couldn't learn new things? You would not be able to remember new people you met or remember what you were told. This actually happened to a famous patient in the Annals of Memory Research whose initials were HM. At the age of 27, HM had an operation for epilepsy that took out his hippocampus on both sides of his brain. The hippocampus has a shape of a seahorse and is named from the Greek hippos, meaning horse, and campos, meaning sea monster. The operation was a success. The epilepsy was cured, but the price was steep. HM could no longer remember new things. He had become profoundly amnesic. Curiously, you could have a normal conversation with HM, but if you left the room for a few minutes, he could not remember you or what you had discussed. In the film Memento, the character played by Guy Pearce had this form of amnesia from a concussion. Note that he tattooed his body with messages so that he would not forget what he had to do. HM could learn other things like a new motor skill, but he could not remember having learned it. There are multiple memory systems for different types of learning. From the studying HM and animals with similar operations, we have learned that the hippocampus is an important part of a brain system for learning and memory of facts and events. Without the hippocampus and its inputs, it is not possible to store new memories in the cortex, a process called memory consolidation that can take many years. HM could remember things from his childhood, but he had trouble remembering things that had occurred in the years just before his operation, things that had not yet become fully consolidated. Something similar happens when you have a bad concussion, but this usually resolves, unlike HM, who never improved. Memories are not fixed, but living, breathing parts of your brain that are changing all of the time. Whenever you recall a memory, it changes, a process called reconsolidation. It is even possible to implant false memories, which are indistinguishable from real ones, by simply suggesting and imagining, especially in children who have vivid imaginations. Here is a summary. The green process of consolidation takes a brain state in active memory and stores it in long-term memory by modifying synapses on the dendrites of neurons. These long-term memories can remain dormant for a long time until the memory is retrieved and reinstated by the red process in short-term working memory. The reinstated memory is in a new context, which can itself be transferred to long-term memory, thereby altering the old memory through reconsolidation. Our memories are intertwined with each other. As we learn new things, our old memories also change. Like consolidation, reconsolidation also occurs during sleep. This is why it is more effective to space learning over time, rather than mass learning all at once. If you want to study something for an hour, you will retain it longer if you spend 10 minutes each month over a semester than an hour on one day. In contrast, if you wait until the day before an exam to cram the material, you may be able to retrieve it the next day on the exam, but it will quickly fade from memory. In addition to neurons, brains have several types of supporting cells called glial cells. The astrocyte is the most abundant glial cell in the human brain. Astrocytes provide nutrients to neurons, maintain extracellular ion balance, and are involved with repair following injury. In this photo of the cortex, the astrocytes are stained green and the neurons are blue. The intricate arms of the astrocytes wrap around the neurons, each embracing thousands of synapses. A recent experiment suggests that these astrocytes may also have an important role in learning. When human astrocytes were put into mouse brains, the humanized mice learned faster. Interestingly, when Einstein's brain was examined to find out what made him so awesomely creative, the only difference that could be found was that he had many more astrocytes than the average human. Could astrocytes be the key to understanding human intelligence? Well, the more we learn about the brain, the more we have to rethink learning. I'm Terry Sejnowski. Happy learning until we meet again.